Welcome to WineHow. We believe real wine knowledge begins where assumptions end. If you want to take your wine knowledge one step further, this short video will cover everything you need to know about a tiny but crucial part of this enormous field. Fans' favorite, sulfur dioxide. And trust us, your next tasting group will thank you for sharing these info with them. So, let's begin. Sulfites exist in wine primarily as sulfur dioxide in equilibrium with its hydrated and dissociated forms, molecular SO₃, bisulfite, and sulfite. Among these, molecular SO₃ is the key active form because it can pass through microbial cell membranes and directly inhibit their activity, and its concentration is strongly influenced by pH. Small amounts of sulfites are naturally produced during alcoholic fermentation by Saccharomyces cerevisiae, but these levels are not sufficient for long-term protection. For this reason, winemakers often add controlled amounts to reach specific free and total SO₂ levels, ensuring proper stability during aging and storage. These protective effects are achieved through two primary mechanisms. So the first one is redox and antioxidant function. Sulfites act as reducing agents, reacting with oxygen-related compounds formed during oxidation. When oxygen enters wine, it triggers reactions such as phenolic oxidation, anthocyanin degradation, and aldehyde formation. These processes lead to visible and sensory changes, reds developing brownish tones and whites losing brightness and aromatic intensity. Sulfites also bind with reactive carbonyl compounds like acetaldehyde, forming stable compounds that prevent further oxidation. In doing so, they help preserve volatile aroma compounds, including esters and thiols, and maintain a stable redox environment within the wine. Another important role of sulfites in wine is their ability to inhibit microbial growth. The antimicrobial effect of sulfites arises primarily from the molecular form of SO₂, which can pass through microbial cell membranes. Once inside, it disrupts internal conditions and interferes with enzyme activity, slowing down or stopping microbial growth. This helps control spoilage organisms, which are responsible for off flavors, volatile acidity, and unwanted fermentation. The effectiveness of this process depends on pH, with lower pH increasing the proportion of active molecular SO₂. Without proper sulfite management, wine becomes highly vulnerable to oxidation, microbial spoilage, and chemical instability. This can result in increased levels of acetic acid, ethyl acetate, and aldehydes, along with a loss of aromatic and structural quality.